Hey everybody, this is Mr. Beckstrom, and today I want to take a look at an example from section 6A. And it says the numbers of words defined on randomly selected pages from a dictionary are shown below. Find the mean, median, and mode of the listed numbers. And I actually want to show you how we could use this to kind of get an idea of how many words are in a dictionary by taking a sample of the number of words defined on randomly selected pages and then looking to see how many total pages there were in that dictionary. But let's go ahead and first answer this question here. So we want to find the mean, the median, and the mode. So we need to define those and then calculate them. And I'm going to do this first by hand, and then I also want to use my calculator. So the mean, we're going to start off with here, the mean. And the way we define the mean, and I'm going to use some Greek symbols here, is the summation. That's a capital sigma. What this means is we're going to take whatever's to the right here and we're going to sum all those together. It's the summation of all our x values. These are the data values that were given. And we're going to divide by the total number of values. That's n. N is our sample size. So in this case, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it'd be n would be 10 in this case, and x would be each one of these individual numbers, and we would sum them all together. So in this case, let's go ahead and pull up the calculator. So let's sum these together. So that's 47 plus 30 plus 63 plus 40 plus 32 plus 59 plus 72 plus 43 plus 61. So I get 488 total from my sum. So that would be 488. And then we're going to go ahead and divide that by 10. And that's going to give us a mean of 48.8 words. All right. For the median, what we want to do is we want to find the middle number. That's what the median means. It's the middle number. And for that, what we're going to do is we're going to put these numbers in a chronological order, usually from smallest to largest. That's usually the easiest way here. So what I'm going to do is I'm going to start with the smallest, so 30. And each time I do a number, I'm going to mark it off here so I know I used it. Or instead of doing that, since I'm going to have to actually find the mode as well, let's go ahead and just put a little number under it. That way we don't mark it off there. And then we've got a 32 there. 32. And I don't think we have anything left in the 30. So in the 40s, I've got a 40, a 41, and a 47. So a 40, a 41, and a 47. And then in the 50s, I think I just have a 59 there. Oh, I forgot a 43, didn't I? So I need to put that 43 in there. 43, 47, and then the 59. All right, so that takes care of that one. And then 61, 63, and 72. 61, 63, and 72. So 61, 63, and 72. All right. So for the median, it's going to be the middle number. Notice there's 10 values here. So for an even amount of values, that would be 10 values, 12 values, 20 values, 2 values, 4 values. We're not going to have a middle number because if you think about it, if I just have 2 values, right, there's not going to be a middle number, right, between them. If I have 4 values, 1, 2, 3, 4, there's not going to be a middle number there because you have 2 on each side. But if I have 3 values, but if I have an odd number of values, there will be a middle number because we can have at least we can have exactly 1 on each side. So The way it works is we have a different case depending on whether we have an odd amount of values or an even amount of values. If we have an odd amount of values, then we have a middle number there. Whatever that middle value is our median. If we have an even number of values, we take the two middle numbers. So 1, 2, 3, 4, 5. It'd be we take this value here. So that'd be the fifth one from this side, and 1, 2, 3, 4, 5, and the middle value from that side. And we'd find the middle of those two values. So to find the midpoint of two values, we use the midpoint formula. That's you add them together and divide by 2. So we would just take 43 plus 47 and divide by 2, and that's going to give us the middle of the two middle values there. And that's going to be 43 plus 47. And then we're going to divide that by 2, and we get 45. And sure enough, 45 is right in the middle. So that will be our median. And finally, our mode. Our mode is the easiest of the three. That's the one that occurs most often. So what value occurs more than every other value? And we can have multiple modes as well. As long as there's at least one value that occurs more than another value, then we have a mode. In the case that there's no value that occurs more than another value, then we say we have no mode. So if we look here, every value occurs exactly once. So in this case, there's no value that occurs more than another value. So in this case, we say that there is no mode. No mode. So no mode. Let me give you an example of something else here. Let's say we had this. Let's say I had 3, 3, 4, 4, 5. In this case, I have at least one value that occurs more than another value because 3 occurs more than 5. So I definitely have a mode, and my mode would be both 3 and 4. So in this case, my mode would be 3 and 4 because they both occur twice. All right. So in this case, I have two modes, and they would be 3 and 4 because I have values that occur more than other values. But if I change this data setup and I just added another 5 here, then suddenly I went from having two modes to having no modes. Because now there's no values that occur more than any other values. So now I just went to no modes. So that's how that works. All right. So now, how can we use this in order to estimate the number of words in a full-blown dictionary? Well, if we took a sample here and we said that there's about 48.8 words per page on the sample of 10 pages that we looked at, and let's say, for example, there were 2,348 pages in this dictionary, right? Then what we could do is we could multiply that by our 48.8, right? And put that in our calculator. And so 48.8 times the number of total pages. And we could say that we think that there's somewhere around 114,000 words, or 114,582 words that are defined in this dictionary. Now, is that going to be exact? No, it probably won't be exact. But is that going to be pretty close? Probably. Hopefully we got a pretty good sample out of that dictionary. How could we get a better sample? By what could we do? We could take a different sample, right? We could find some way to take a random sample where maybe we choose the pages in a completely random way, right? Maybe we use our Google Assistant or our Siri or our Alexa to do a random number generator between 1 and 2,348. And maybe this time we do our sample size a little bit larger and we pick 25 pages. And then we check this to see if this changes dramatically, this average of 48.8. And if we do that a couple of times and we're still really close to this 48.8 average words, then that's gonna give us a more comforting idea that this is pretty close to the true number of words defined in this dictionary. All right, guys. I hope this helps. If you have any questions, please let me know, and I hope you have a great rest of your week. Thanks.